So, hello everyone. We will start our talk and then people will join us in between. So, we will going to talk about motion and the central forces, and this is the topic from classical mechanics. And that lecture is part of NPTEL GATE physics course. So, we will start it. So, till now we have been talk about the electromagnetism part of GATE physics course, in which we will talk about the charges under the influence of electric field. Here we are going to talk about the particles which are then under the influence of central forces, and we will see how this particle is going to behave in the central force. For example, you may consider that there is some area in which there is some forces, and you can consider it here as central forces, and then we wanted to see how this particle is going to behave as it is moving inside the central forces, what will be its trajectory, and what is the force that is going to act on it, what will be its energy. So these kind of things we will talk about here, and then we will solve 2 to 3 questions from GATE exam that was appear in previous years. So, okay. So the problem that is generally encountered in central forces is we have a kind of force which is always towards a point, and you have another particle here, and this particle is ap- going to face this force which is always towards the center of this point. For example, you may have the particle position at some other point that is again going to feel the force towards the center, or it may be at another point again it's going to feel the force towards this point center. So this is the property of central forces, that your direction of force is always going to be towards a point, and the force magnitude of that force depend on the distance of that particle from that point. For example, you may have this XYZ coordinate system in which the point is at the center. So your particle is at a distance r. So the particle is going to face the force that can be towards the center, or it may be away depending on the kind of force, it is attractive or repulsive, and the magnitude of that is depend on the distance of that particle from the center. So this is the kind of force which is represented by the central forces. The magnitude depend on the distance, and it always going to be in radial direction. This direction is known as the radial direction. You may have two body problems as well. For example, you have mass M1 and M2, and they are placed at a certain distance. In that case, you can consider that the particle 1 is maybe heavier than the particle 2. Then you can consider this as a point and this as another particle. So your problem will get changed towards this central force problem. And all these problem, for example, the planets are moving around the sun, the satellite moving around the earth, the Kepler's law and Newton's law. They are all kind of forces that is coming under the category of central forces. So to understand the mathematical part of the central forces, first we will understand the concept of polar coordinate system. You are all familiar with this concept of Cartesian coordinate system, in which you have x, y, and z axis. In polar coordinate system, you have r axis and theta axis. They are all perpendicular, but how they are related to x, y axis is the r direction will make an angle theta with the positive direction of x axis, and the theta direction is perpendicular to this r. So this is how this is theta cap direction. So they are perpendicular, and r cap direction make an angle theta with positive x-axis, and x is related to r by r cos theta, and similarly y is related to by r sin theta. So it just the composition of this coordinate system in x and y direction. For example, if you have theta, then you can just write it as r cos theta in x direction and r sin theta in y direction. It's a decomposition of this r cap axis in x and y coordinate system. So generally, you can always write your r cap axis in Cartesian coordinate system, x cap and y cap. Similarly, theta cap can also be written as in terms of x cap and y cap. For example, theta makes an angle 9 theta with y. So that means 90 plus theta with x axis. So you just add 90 plus theta, you will get theta cap direction. Similarly, here. So why we are doing all this? Uh, Means why we are trying to understand the concept of polar coordinate system, just to see how the velocity of this particle is going to change in in central forces. For example, if you wanted to write the velocity of particle in Cartesian coordinate system, you can simply write dx by dt. But if you wanted to write in polar coordinate system, then simply writing dr by dt will not give you the correct answer. So to calculate the correct answer, we will move into this polar coordinate system. So if you wanted to write r theta cap and then xy in matrix form, this thing can be written in this way. So you know that your r cap is given by this relation and your theta cap is given by this relation. So you will calculate dr by dt, how the rate of change of this direction with respect to time t, because you wanted to know what is the velocity. So your dr cap by dt, you just differentiate equation 1 with respect to theta, with respect to t, and apply chain rule, then it will become this form, and you just take theta cap dot outside, so it will become theta dot that theta cap. I think you will get this, how this dr cap by dr cap by dt will change to theta dot by theta cap. Similarly, if you differentiate the equation 2 with respect to time t, then this will become minus cos theta and with chain rule d theta by dt, and similarly sin theta d theta by dt. You just take d theta outside, then it will become minus r cap d dot theta dot. So you have dr cap by dt and d theta cap by dt. So the position vector in polar coordinate system is given by, I think you already know that the position vector is represented as x in the x cap, y in the y cap. I am just writing I cap by x cap and j cap by y cap. So it's just the same thing. And putting the value of x as r cos theta, y as r sin theta, and taking r outside, this will become magnitude of r in the r cap direction. Similarly, if you calculate velocity vector, you just differentiate the r vector by dt, and r vector is given by magnitude of r in the r cap. So you differentiate magnitude, you will get the r by dt, which is r dot. Then you have to differentiate r cap, dr cap by dt, and we have already calculated it is given by theta dot by theta cap. So your velocity vector in polar coordinate system is r dot in the r cap and r theta dot in the theta cap. So this is your radial velocity, which is generally in the radial direction, but you again have the component of velocity in the theta cap direction, and this component is given by r theta dot, and this component is similar to like angular velocity part. So your total velocity will be radial velocity plus angular velocity, which is in theta direction. So your total velocity will be square root of radial component plus theta component square. So this is your total velocity. Similarly, you can also calculate the acceleration in polar coordinate system, and this we will use to calculate the forces, since forces is given by m into a, and we cannot write a as simply d2r by dt square in polar coordinate. It will give you wrong answer. So to calculate the acceleration, we differentiate v with respect to time t. Again, r cap differentiated, r dot differentiated separately, r cap differentiated, and then theta. These terms are differentiated all by applying chain rule. So this is just by applying chain rule. And then when you write dv by dt, this will become, I just write r dot, I think dr by dt, and r double dot as dr 2r by dt square. So I just replace it here. And whenever I have encountered dr cap by d theta dt, I just use this relation and d theta by dt used by this relation. So by putting all this value, this is the acceleration part will contain component in r cap, component in theta cap. So just by combining r cap component together and theta cap component together, so we are left with two part of acceleration, one in the radial direction, which is related to r cap component, and one in the theta cap direction, which is the angular part of this acceleration. So this acceleration is the radial acceleration, and this is the tangential acceleration. Tangential, or you can say angular part of this angular acceleration. So you have this force. Similarly, you can write force as m a vector. A vector is simply ar in the r cap direction and a theta in the theta cap direction. So MAR will give you component of force in the radial direction. So this will become your force in the radial direction. Radial direction means the direction which is away from the center or of this point. And theta cap direction is towards this angular direction, which is tangential to this circle here. So these are the component of force which is acting in theta, and this is the component of force which is acting in radial direction. So now there are special case. For example, your particle
Excuse
is
me.
moving in. Yes,
Ma'am, could you please explain tangential, how to convert from the angular to tangential?
angular. Actually, I am using angular and tangential as a same terminology. You can use one of them.
Ma'am, A is equal to AR dot R plus A theta dot theta. यहाँ तक की value we have got. Then after we are taking the value of AR and A theta. That value I didn't get.
Yes. How I encountered with this value of AR and E theta, how
Yes,
this value came.
yes.
Actually, these are came from this derivation of velocity. We start with the position. See, if I will try to explain it in simple term, in Cartesian coordinate system, we have x cap and y cap. These are our position coordinate system. So if I wanted to write our Cartesian coordinate system, then position is given by x in the x cap direction, and the velocity is given by dx by dt in the s cap direction. Similarly, acceleration given by dv by dt. So here in position vector in radial coordinate system is given by magnitude of r in the r cap. Then I differentiate this component to get the velocity. So dr by dt is just differentiation of this term. But here r cap is also depend on time. So we have to differentiate dr cap by dt also. And we have seen that dr cap by dt is given by this relation. So we put the value of dr cap by dt. So our velocity have two component. One is the r dot in the radial direction, another one is r theta dot in tangential direction. And this just come from the chain rule perspective. See your dr cap by dt, this is give you value theta dot in theta cap direction. So you write theta dot in theta cap. So this quantity will give you tangential in theta cap direction. And when you differentiate dv by dt, again you differentiate every part of it. R dot, R cap, theta dot, theta cap. All these components you have to differentiate and then put the value of dr cap by dt. Similarly, d theta cap dot by dt. And they are just changes your r coordinate r cap to theta cap and theta cap to r cap. So when you put this value and combine r cap together and theta cap together, that will give you the radial and tangential component. So it's the differentiation part which change your r cap, dr cap by dt to theta cap, and the theta cap by d theta to r cap. Hmm. Are you able to get this point?
Yes, ma'am. Thank you.
Okay. Okay. So this is your radial component of acceleration and this is your tangential component. Similarly, you will get the force. The property circular motion is a special case in that sense. Your radius is always going to be fixed. So basically, if you are not this is the radius. So if, when you take a rope and you start moving in circular direction, you tied a particle to it and you start rotating it in a circular direction. So your radius is always going to fix. In that sense, if you calculate dr by dt, it is not changing with time. So your dr by dt will become zero. So your r dot will become zero. So if you put r dot or r double dot both terms zero in this two equation, then this will become your radial force m r naught theta dot square, and this is will become your tangential force. And for the case of uniform circular motion, you means you do not want any acceleration when it is moving in circular direction. So you want that there will be no tangential component of force in when it is moving in circular direction. So you put your f theta as zero. In that case, your mr theta double dot term will become zero. So this is condition for uniform circular motion. And when you put this term d2 theta by dt square as zero, then d theta will become constant. You just integrate it. So one term will get out and it will become constant. And this constant you can say it is the angular velocity. D theta by dt is just change in angle of your rotation. So your theta dot is the angular velocity and radial velocity which is given by r cross omega, and r and omega are perpendicular to each other. So you can simply write it as r omega or r dot into theta dot. So your this quantity mr theta dot square kind of become constant for this case of circular motion. And in radial direction, if you look at, you put r double dot zero, that means r theta dot square term will left, and you can put the value of theta dot as v by r zero here. And from that, if you look at, it will become v square by r zero. This is the same kind of, centripetal forces that you have encountered in your 10th class. So this radial acceleration will lead to this centripetal acceleration in case of uniform circular motion. So you will see that the term that you have read in your 10th classes, it just can derive when you write all things in polar coordinate system. So it will be much easier to learn these concepts in polar coordinate system. Okay. We will also see there is other properties of circular motion as well in next part of this talk. Now let's come back to our central forces, and we already know that we wanted to see how the motion of particle is going to change in presence of the central force. And there are certain property of these forces. One is that it is conservative in nature. For example, if you calculate the curl of these forces, it is going to be zero since it has only the r cap part. There is no theta, there is no phi. So if you calculate the uh, curl of that, this will be going to be zero. And we already know that whenever we have a vector quantity whose curl is zero, we can always write it is in terms of gradient of some scalar quantity. And this scalar quantity here is the potential energy. So the property of central forces is that you can always write a force as negative gradient of your potential energy. And since your forces generally always depend on the distance of this particle to this point r, so your gradient is generally changed to minus del v by del r. So you always see that whenever you have encountered these forces, you can always write your force as minus del u by del r, where u is the potential energy. Next property is that the angular momentum is going to be conserved. For example, if you calculate the torque that is acting on this particle, it is given by this formula r cross f. Your f is in the radial direction. This is the from the definition of the central force, and your r is already in radial direction. And when you calculate the curl of that, it will become with 0. And since you can always write your torque as the rate of change of angular momentum, similar to like force as rate of change of linear momentum. So your torque is rate of change of angular momentum. So your angular momentum is going to be constant. And since it is given by r cross v, so you have a radial direction, you have a velocity direction, and r cross v give you direction of angular momentum. So your r cross v is always going to be constant. So that means if your angular momentum is perpendicular to this plane of paper, and then your r and v are kind of with a plane of paper. So your motion is always going to be in a plane, and this is the plane of this orbit. So your orbit always going to be in a plane, and this is coming from the conservation of angular momentum part. So this is the point from this. Next part is that we are going to use a lot in solving the problem from GATE exam, that we can always write central force as Fr in the arcade direction, and we already know that there is no theta component. See, if you have a vector force which is in radial direction plus theta part in theta cap, we do not have that from the definition of central forces. Your shared F theta is 0. That means you can put your acceleration a theta term here as 0, which can also be written as d by dt of this term as 0. And we already know that we can write v as r theta. So this term can be written as mr square theta dot. So you can always write your angular momentum as mr square theta dot. So theta dot always replaced by L by mr square. L is the angular momentum, m is the mass of particle, r is the distance of particle from the center. So whenever in problem you will see the situation arises in which you have to write theta dot, you always replace it with L by mr square. So this is an important formula from GATE perspective. And this is also helpful in explaining your Kepler's law of motion. So you are familiar with this Kepler's second law of motion, which says that equal area will kind of being covered in equal time. For example, if your particle is near to the center, then it cover much orbit range, but the area covered within this area, distance and within this orbit range, they are both going to be same. That means area velocity dA by dt is going to be same. And to prove this concept, what we can do is we calculate what will be the area covered by particle when it is moving a distance d theta. So if your particle initially at this position and finally at this position, and it move by a distance d theta, and this is your distance of particle from the center of point, then you can say that this is the rd theta distance which is covered by particle within the time t. So you can calculate area as 1 by 2 base into height. So base is your r and theta, height is your rd theta. So this is your area, and area velocity is dA by dt. So you just take dA by dt here, so it will become d theta by dt. And you already know that the theta dot can be replaced by L by mr square, and L by mr square is kind of constant. Since L is constant, so your dA by dt will become constant. So your Kepler's second law of motion is can be derived from this only equation, that your angular momentum is conserved. Okay, and now comes to the total energy of the system. The total energy is generally conserved for the case of central forces. That means it does not change with time. So your daily by delta is always going to be zero. It will not going to change with time. And when you try to write the energy of particle, is write kinetic energy plus potential energy. And you already know that your V contain radial part as well as angular part. So you just put the value of V square, which is r dot square plus r square theta dot square. This is how we calculate. If we have Vx part plus in the s cap direction, Vy in the y cap in Cartesian coordinate, then we can calculate the magnitude of Vs px square plus py square. So here just we are writing in radial coordinate system. So we just put the value of v square here. This is your potential energy. And by replacing theta dot again by L square by mr square, we can say that this term is depend on r dot. So time derivative part. This does not depend on any times of derivative. So we take these two terms together. It is also a function of r, it is also a function of r, and we call this effective potential. So we can always write effective potential as L square by 2mr square plus Vr. And this is also very important formula from gate perspective. You can directly apply it to solve the problems. So your total energy can be written as 1 by 2mr dot square plus V effective, and V effective is your effective potential. And now you can see that you can also derive the circular orbit conditions from this V effective part. So circular orbit require that your force is given by radial force is there is given by mr double dot r theta dot square, and r is constant for the circular orbit, so your r double dot is 0. So you put the value of theta dot here. So this is your radial force in case of circular orbit. But if you take v effective and differentiate it with respect to r and put it equals to 0, you can also arrive at the same formula. So you just write your v effective, differentiate with respect to r, put the value f of r as minus del v by del r. This is we already know. We can write gradient of potential energy as force. So your force will become minus L square by mr cube. So this is a very important condition for the circular orbit, that you can always write the effective potential and you put del V effective by del R equals to 0. So in GATE exam, you will encounter that you always given different types of VR. So this quantity will get changed. So only you have to write V effective, put R equals, differentiate it, and put R equals to R naught. So for this case of circular orbits. There is sometime also says that instead of moving circular orbit, you just kind of give slight perturbation and your orbit kind of changes to another orbit. So what will be the oscillation frequency of that? So this kind of question generally came in exam. So what you can do is, we already know that del V effective by del R at R equals to R naught is 0. So from there you will calculate what is the relation between L and R naught. And from that, then again calculate del 2 effective by del R square. And we know that from differential equation. So if you have a function del f by del x equals to 0 and del 2 f by del x square is greater than 0, that means at f equals to some point you calculate x naught. That means f equals to x naught, the function has some sort of minima. So that will help in finding what is your oscillation frequency. So this is the oscillation frequency which generally directly used if you have delta effective by del r square greater than 0, then the angular frequency of new orbit can be calculated directly by this formula. So this kind of question, formula based, that is you will encounter in exam. So this is only applicable when you have initially some orbit and it get perturbed and then you have new orbit. For this new orbit, this is the case. And there is one more type of question that is that you have seen. It is based on equation of orbit. So you already know that for the case when your potential is given by Kepler's law, like G capital M small m by R. So when your potential have this kind of form, that is your potential depend upon 1 by R as a distance. In that case, you have an orbit which is elliptical orbit. So your planets are moving in elliptical orbit. So we just try to derive this condition of elliptical orbit from the center force equation. So if you wanted to like the equation of motion for the particle when it is in central force, You can write the Lagrangian as, I don't know how much of you are familiar with this Lagrangian thing. We will cover that in next lecture. But if you have a central force and you wanted to write the Lagrangian of something, you can just write kinetic energy minus potential energy. So your kinetic energy 1 by 2 and v square, we write the value of v square here minus potential energy. And when you have two particles instead of one, you just take the center of mass of this particle instead of m. So this is your Lagrangian, and the equation of motion in terms of Lagrangian is given by this. So this is the formula for writing equation of motion in terms of Lagrangian. So you differentiate with respect to r dot, this term. So only this term will contribute, so it will become mr double dot. Then you differentiate with respect to r, this term will contribute and this term will contribute. That will give you mr theta dot square term. And this is, then you replace minus del v by del r by radial force Fr. So this is your equation of motion in central force case, and a particle is moving in central forces. Now we have to find the equation of orbit. So what is mean by equation of orbit? We wanted to find our function r as a function of theta. Means how our r is vary as it is moving along the different direction theta. So this is we wanted to find out. So to find out that, we have considered a variable u which is equals to 1 by r. Just started our calculation with as 1 by r and then differentiate it r dot, since we have to put everything into this equation. So we wanted to know r double dot theta dot. So we just differentiate r dot and we just replace it by chain rule in terms of theta dot term. So this is our r dot in terms of theta. We replace the value of theta dot in terms of L, and then r square will cancel out, it will become L by N. Similarly, we calculate r double dot. So this term will become again with chain rule theta dot term will arise and we replace L square by M here. So this is our r double dot. So we put this value into this equation of motion, mr double dot, mr theta dot square and equals to Fr. And we also replace theta dot square by L square by M term. So when we solve this equation, this is become the equation of orbit. So the equation generally used directly in GATE exam. This is when you are given different form of forces and you wanted to calculate what will be the equation of orbit for you. So different forces, this equation is still valid. Just replace your 1 by u by r in this equation. Okay, for example, you are given a potential PR which is equals to minus KR, which is the Kepler potential with K equals to G capital M small m. So your force will be minus del V by del R. So it will become the form of K by R square. So this is for the case F, you just replace FR by KR square. So minus KR by R square and 1 by R square is replaced by U square. So just you put all this value in this equation, then equation will be take this form and you just introduce a variable y such that you can write in more simplified form as u minus mkl square as some variable y and your d2 y by d theta square is same. So this your equation will become the standard form, and the solution of this standard form equation is simply y equals to a cos theta. If you put this value in this equation, the equation is going to be satisfied. So you just put value of as a cos theta in the here, and this is your equation of orbit. You can write u as 1 by r, so you can calculate how your r is varied as a function of theta. So by putting the value of L square by mk on this side, a is constant here that depend on the boundary condition, different type of boundary conditions. So this equation is the equation of orbit when it is moving in a potential, which is the Kepler's potential. So if you are seeing the question in which potential is Kepler potential, you can directly use this equation. And this is the equation of conic sections. And generally, when we try to write the equation of a conic section, for example, this is some conic section, and we wanted to write an equation, it can always be defined by some distance d from a fixed line and towards the distance r from the center of this conic section. And this is known as, and this ratio of distance r by d is known as eccentricity. And depending upon this eccentricity, you may have parabola, hyperbola, or ellipse. So if you wanted to write the equation P here, the distance, how much the distance P will be, so you can write D plus this distance, which is r cos theta here, projection of this. So you just replace uh, small p as some quantity epsilon times of P, just to make simplification. So your equation will become r equals to P upon 1 plus cos epsilon cos theta. And if you look at this equation and this equation, to this equation 2 can also be written like this. All you have to do is just replace P by L square by MK term is replaced by P, and A L square by MK term as eccentricity E. So when you put that into the equation, this equation will take the form of conic section. So this is your conic section equation. And for the case of Kepler's potential, Vr is minus K by R. So we have just to see how the different eccentricity will give you different equations for the ellipse, hyperbola, and parabola. So if your total energy can be written as 1 by 2 mr dot square plus V effective term, so your potential equation of orbit, it becomes P by R 1 plus epsilon cos theta. I just replace this term P and this term epsilon, and we differentiate it and calculate the value of R dot, theta dot, put this into the equation E, and we find a solve this equation and find a relation between the eccentricity and the energy E. So this is a very important relation that can be used directly. So whenever you have the energy which is greater than zero, that will lead to you a condition of hyperbola because your eccentricity will become greater than 1. When your eccentricity is 1, it will become the equation of parabola. In that case, your energy is 0. When your eccentricity is 0, that will become the equation of circle. In that case, your energy is given by mk square by 12 square. And in case when eccentricity is less than 1, this will lead to ellipse, energy is less than 0. So in case of planetary orbit, you know that it is an elliptical orbit since your eccentricity is less than 1 and your energy is also less than 0. So there are two important equations which generally directly use. One is this and another one is this. So you have to remember these conditions under which you can get different kind of equations of conic section. So now we will see some question that was appear in GATE exam based on this concept. So this was the question from GATE 2012. In a central force field, the trajectory of particle of mass m and angular momentum L in a plane polar coordinate is given by this equation, where epsilon is the centricity of particle motion. Which of the following choices for epsilon given rise to a parabolic trajectory? So the question asks directly. But if you look at this equation, this is the one that we have derived for the case of Kepler's potential. So you already know for the case of Kepler potential, parabola will be the case when your eccentricity is 1 with these conditions. So here is a directly formula this question. This was the question from GATE 2014. A particle of mass m is in a potential given by Pr equals to minus A by R. So your potential form had changed in this question. So where A and R0 are positive constant. When disturbed slightly from its stable equilibrium position, it undergoes simple harmonic oscillation. What will be the time period of oscillation? So generally, if you have a particle which is moving under some central forces and it is moving in a very stable orbit and you slightly perturb it, and it will give simple harmonic oscillation if it is in stable equilibrium condition, and that will means del 2 v by del r, del 2 v effective by del r square should be greater than 0. So we know our VR, we calculate what is V effective. Actually, I haven't calculated V effective here. This is my mistake. I don't know why I haven't calculated it here. But the main conditions for this case is del 2 effective by del r square should be greater than 0, and that will give you the condition for the equilibrium. So we calculate differentiation del v by del r, and from that we will find a relation for the r value. We have two values for r. One is plus r naught and minus r naught. We only choose the value for which del 2 v r by del r square is greater than 0. So we calculate del 2 v by del r square for this value of plus r and minus r naught. Here I am just putting the value of plus r naught, which give you the value which is greater than 0. And by putting this value, we will able to calculate the value of angular frequency, and time period is related to angular frequency by 2 pi by omega. So this is your time period of oscillation. 2 pi mr naught is cubed by 2a. So this one is the correct answer. You people will check it if it is true for del 2 effective by del r squared too. Since the condition is this, not this one. I have done this thing wrong here. So this one is the correct condition. Sorry for the some I have done it in hurry. Okay. So there is this question from Gate 2014. A planet of mass m move in circular orbit of radius r naught in a gravitational potential Vr equals to minus k by r. What will be the angular momentum of the planet? So you have given potential Vr, and the condition is circular orbit. And the condition for circular orbit is del effective by del r at the radius r equals to r naught should be 0. So we write there the V effective, which is L square by 2mr square plus VR. So VR is minus K by R. We put their value equals to 0, and we will calculate what will be the angular momentum L, which is square root of K m. So there is one more question from Gate 2015. A satellite is moving in a circular orbit around the Earth. So it is given that it is a circular orbit and a satellite is moving around the Earth. If T, V, and E is kinetic energy, potential energy, total energy, how they are related with each other. So we have not given the form of potential here. So just to make our case simple, we just take a very simpler form like r to the power n plus 1. And we already know that we can simply write our potential for the case of, you know, Kepler potential as minus k by r. So if you wanted to write it, we have to replace n by minus 2. So just we calculate the situation for general case, and then we will apply the case of Kepler potential. So we just take a general case of potential energy as k r to the power n plus 1, and we put del v by del r, we calculate it, and we already know that for circular orbit, del v effective by del r is 0. From there, we will calculate the relation between L and R naught. Then we write the kinetic energy. Since we have to know how the kinetic energy is related to potential energy, so the kinetic energy is given by mv square. We contain these two terms. R dot is 0 for circular because R is R naught constant. So we have left with this term. We replace theta dot by L square by mr square, and the kinetic energy will become this. Then we replace the relation of L square by this term here. So we found that the kinetic energy is given by this, which is related to potential energy by this relation. Since we already take potential energy, this, so this one is the potential energy. So for a satellite case moving around the Earth, we just replace our potential by Kepler's potential. That means we have to replace n by minus 2 here. So our kinetic energy become minus 1 by 2 times of V, that is V is related to minus twice of kinetic energy. So V is related to minus twice of kinetic energy. And if we calculate total energy, this is kinetic plus potential, it will become minus of kinetic energy. So this is the correct option here.
And when we initially take KRN plus 1, then it is always
Yeah.
a constant for the all type of question like this.
K is constant.
No, I'm asking like that. When we take the potential energy V is equal to KRN plus 1, then it is
Yes.
constant for all the question like this. Uh,
Yeah, this is valid for all the central forces. I have shown uh, here for the case of Kepler potential, but this formula is valid for all potentials. You just simply replace the form and values depending on what is given in your question.
yeah, we have let that value, right? Yeah, or we know before that the value of potential energy. I'm asking that do we know before the value of that, or just we let the you casually?
We can simply use that formula directly for any potential if it has simpler form. But if you're, for example, something like this form, but if your potential is having like one terms AR plus D by R square, then you cannot use directly this formula. Then you have to kind of derive this thing.
Okay, if it is not given, then we can use like this, right?
For any simpler kind of potential, you can directly use this.
Okay, okay.
Okay. Okay. This question from GATE 2018 exam. So, question number 27. An interstellar object has a speed v at the point of its shortest distance r from the star. So, it is given that uh, there is an interstellar object which has a speed v at a point of shortest distance from a star, let's say it is Sun, and have a much larger mass m, and v square is given. What will be the trajectory of particle? So, it is given that the shortest distance is this one, the longest is this one. So we have to calculate what will be the trajectory. So whenever you wanted to calculate trajectory, either look for the eccentricity or you look for the energy. So here it is given to us v squared, so we can directly use kinetic energy plus potential energy term. So your energy is given by 1 by 2 m dot square plus v effective, and at the shortest distance r dot is 0. So the energy is given by L square by 2 mr square plus v effective for the Kepler potential minus k by r. K is given by this term. And we already know that the angular momentum is given by mvr equals to L. It's just a relation m cross r cross v, sorry. And we differentiate, square it, and from the v square value, we just put what is given to our equation. Then we can write our L square in terms of these k terms. So the put the value of energy here. R dot term is 0, so only the effective is the term. So this is our energy. Put the value of L square and K by R. And when you see, this will come cancel out each other. So energy is 0 for the case of parabola. So this four condition you have to be remember. So the trajectory of particle in that case will become parabola. These are the questions that I have found in last exam. Let me know if you wanted to ask any other question. If there is something that you do not get or wanted me to explain it again. Yeah, you will get these notes. I will upload my YouTube link onto which you can see these notes. Or I will share the YouTube link here since we have been told not to share the YouTube links. So I will share YouTube link here in the chat box. So you will see that. So you will get these notes by today evening. I will upload everything. Is there any topic that you want me to cover in next class? Anything that you want me? We will do that.
Ma'am, which
Madam,
books prefer?
You can explain one by one.
Okay, ma'am.
Lagrangian mechanics. Okay.
Okay.
hello.
Anush Mishra, you are saying something.
Ma'am, I'm asking that which book we can prefer for classical mechanics preparation for short time.
For short time
Yes, ma'am. Just we can go for concepts and yeah, that is
of
a very
questions.
clear cut, ma'am. That's why I'm asking.
Hello.
Okay, I will answer your question. Yeah, someone is asking something. Yeah, you can ask Galaxy A21 as the name. And for classical mechanics, I will say if you can find some coaching notes, that will be much easier because for coaching classes, it will be very handy to solve that paper. Otherwise, I will give you in next class. There is one book in which concept is explained very easily and there are a lot of questions. I have to see it in my library. Can I provide you in next class the book name? Okay.
Madam, can you please share me the link to join the group?
You can join the group from, you know, this
Sorry,
NPTL
madam, I
class.
can't hear you.
Uh, aren't you able to get the access from NPTL Gate lectures? You just search on Google about NPTL Gate Physics course, and there you can find all the links. There are a lot of classes going on.
Not about the classes, madam, to access the material that you are sharing now.
Okay, so that material you can see on every lecture. I will upload all the PDF notes on this YouTube channel that I have shared the link in chat box. You just search it. Lagrangian and
Okay,
Hamilton.
madam.
I will cover in next class.
Thank you.
Okay, so next class will be on Lagrangian and Hamiltonian. Okay, okay, then we will finish today's class. Thank you. Bye bye.